Thank you very much. Thank you for the nice introduction. I'm super happy to be here to spend 45 minutes on a very interesting topic. Because if you ask me, our world has changed in the last few years. Our computers have learned to speak natural language. Everybody's talking about artificial intelligence, natural language processing, and particularly OpenAI. And this is exactly what the next 45 minutes will be all about. It will be a .NET State of the Union talk. If you are a .NET developer, what can you use? Which SDKs do you have? What advantages do you have if you use .NET? What disadvantages do you have if you use .NET? And I will talk about exactly that. Now, you know, if you propose a talk like that for a conference, you do that month before the conference. And it was a little bit risky because when I proposed this talk, there were just a bunch of preview SDKs out there from Microsoft, and I didn't really know what to expect. Now, I worked on a lot of samples, and approximately 10 days ago, guess what happened? The entire SDK was sundowned. It wasn't even production. It was in beta 18, but still, it was dead. A completely new SDK came out. OpenAI, the company behind ChatGPT that you probably all know, otherwise you wouldn't be here, they announced native support for .NET. They announced a brand new SDK which is around for approximately 10 days. And of course, we are going to take a look at exactly that version of the SDK. For me, that was quite a bit of stressy 10 days because I had to throw away all of my samples and rewrite them, but that is not your problem, that was my problem. So, let's get started. I assume that everybody in this room is at least a little bit familiar with ChatGPT or the GPT large language models. I assume that everybody in this room is capable of at least reading and understanding C#. That's another very important thing. And I assume that you have a little bit of knowledge about the OpenAI SDK on a web services basis. If not, bear with me, you will understand the basics here, absolutely no problem, but probably if you haven't worked with the OpenAI SDK before, you will need to do some additional reading after this talk to grasp all the details that I'm going to talk about. Okay? And with that, without any further ado, let's jump right into the topic. The sample that I'm going to show you is available online, and if you want to have it, just grab your phone, take a picture, and you have a link to GitHub. Of course, you can also link yourself up with me in LinkedIn. I will do a post after this talk, and I will also add a link to the GitHub repository. So you do not need to take notes. Whatever you see me doing in the next 45 minutes, you can look it up in GitHub. If I was too fast, please let me know. I will show you. I will give you the link later on. Oh, I forgot something. If you want to get in touch with me, this is my digital business card. On the right lower corner on this website, you see links to various social media platforms like YouTube and LinkedIn and so on. Just use those links to get in touch with me. I think that is the most simple thing to do. And now, into the topic. Ladies and gentlemen, let me introduce the reason why I spent some nights awake in the last 10 days, the OpenAI NuGet package. This is the brand new NuGet package that has been available only for a few days. Let me prove that. See? This is the old one. Forget it. It's not interesting. This is the new one. Here it starts to be, it was 13 days, not 10 days ago. This is where it becomes interesting. So if you have already looked at this NuGet package, because it has been around for quite a while, forget it. It's outdated. It is still there, but it is only a companion package to this package. This is now the official .NET SDK directly delivered by OpenAI. So you do not need an SDK from Microsoft anymore. Not that Microsoft is creating software that is not good. I'm not saying that. But for me, it's very good news that OpenAI officially now supports .NET. So they support JavaScript and TypeScript, Python, and .NET. However, if you take a look at the API reference, for instance, and maybe let's take a look here, then you will see that their documentation hasn't been updated yet. So you get code samples in Python, you get code samples in Node.js, and I really sincerely hope that in the next few months we will see .NET directly in their online documentation too. That would be awesome. That would make developing even simpler. My last tip before I go into my code is this URL here. You see, this is the GitHub repository of the new OpenAI .NET SDK. And there is a super important folder here. It's called examples. It is gold. It is purely gold. If you want to find out how to work with this SDK, take a look at these examples. I will be your, let's say, tourist guide for the next 45 minutes, but probably you will need some additional samples. You will have additional questions. Of course, you can ask me, but you can also take a look at this repository, particularly this folder, and it will answer a lot of your questions. Okay? They created examples. Let me show you that. They created examples based on scenarios. So if you know what you want to do, you can simply take a look at these scenario samples and you can take it as a basis for your own development. Okay, are we good? So we have a new SDK NuGet package. The Microsoft NuGet package is a companion package. I will show you when and why you still need it. You have a lot of examples, but unfortunately the official docs do not cover .NET yet. Hopefully it will come up later. The rest of my 45-minute talk will be, again, a bunch of scenarios, and I will show you and walk you through code. And of course, we will try this code, and I will show you how the SDK works, so you have a good understanding. You leave this talk with a good understanding how the SDK is structured, and you can start developing immediately after this talk. Let's see how it goes. Now, I have set up a small console application here. This console application is nearly completely empty. It only contains a bunch of user secrets. So I have, before this talk, set up an Azure OpenAI deployment. I've set up an OpenAI deployment. I've set up some SDK, some API keys and things like that. That is really just setting up the project. The second thing that I did, and now it becomes interesting, is I added this NuGet package and this NuGet package to my configuration. Please note that both of these NuGet packages are still in beta. That's kind of a downer if you ask me. In 2024, we still don't have any production SDK for .NET for OpenAI. To be honest, I'm a little bit disappointed about that. So if you want to use .NET with OpenAI and you do not want to call the REST APIs directly, you have to be brave and use beta software. I'm super sorry. You don't have anything else. I hope these libraries will get out of beta soon. Good. So this is what I have set up. Let's start with the very first scenario. I will copy in code because if I talk and type at the same time, I usually make a lot of mistakes. And I don't want to bore you watching me making typing mistakes here on stage. So I decided to focus on code walkthroughs. Now, this is the first scenario. Let me uncomment that, and now we are good. Let me draw a little bit. The first thing that I would like to draw your attention to is this first line here, this one. This is how you create a client. You have various clients. You have a chat client for the chat API. You have an assistant client for the assistant API. You have an embedding client for the embedding API. So depending on what you want to do, which API you would like to use, you have to use different clients. At the end of the day, these clients are just generated wrappers around HTTP client. So the whole SDK is just a tiny wrapper around the REST API that OpenAI provides. Just in case that you're not familiar with this API, you can take a look at the docs at the API reference here, and you will see that the API is really not complicated. No fancy OpenGL or GraphQL or something like this. Really simple REST API. Well, simple. It has a lot of parameters. You get a lot of fields back. So it's not simple as in the API is simple. It's simple as the structure is not super complicated. Okay? Good. So let's take a look at this chat client that I'm using here. For those of you who are rather new with the OpenAI API, the chat API is the current production API for OpenAI. So this is what you use if you want to use the production API that OpenAI and or Microsoft provides in Azure. The other API, the Assistant API, which I will show you a few minutes later, is currently also in preview. Preview means, in my experience, you can use it. It's rather stable, but be aware that it might be broken. So it's not a stable API yet. Okay? It's okay, it's reliable, but it's not stable yet. Now, as you can see here, you have to provide the modal that you would like to use, and you have to provide a key. You get the key from the website. I'm using the latest and greatest modal of OpenAI, which is GPT-4o. O stands for Omni. It's their most intelligent, most powerful, fastest modal. I will focus just on text, but it would be capable of understanding images, of seeing if you want. It would be able to generate images, but I'm not going to talk about that because I only have 45 minutes. Now, let's take a look at this code here. This is the code that I would like to draw your attention to. The API is rather simple. First, you have to put together the communication, the communication thread, the thread of messages that the user exchanged with the AI assistant. The important thing, for those of you who are not that familiar with the API, the important thing of the chat API is that you, as the .NET developers, you have to maintain the communication thread, the list of all messages. So when you want a response from the AI, you always have to send the entire communication thread to the REST API. It has no memory at all. You have to remind the AI over and over what it said in the past. That means with each call to the AI, you can also manipulate the communication thread. If you want to throw out some messages just to make the thread shorter and save some money, you can do so because it doesn't have any memory. It's really completely stateless. So with this API, what you need to do is you need to maintain a list of chat messages. Well, in real life, that's way more complicated because in real life, you have a cluster of machines. So you probably have to have some kind of store, a database or something like this where you store your communication threads. You have to do that on your own. Okay, very important thing. Now then we have an endless loop where we can ask the user for his or her input, and then there is essentially only 3 steps that we need to keep in mind. First, we have to add what the user said to a list of messages. That's the communication thread. Then we call complete chat. There is an async version and a blocking version of this API. Choose whatever suits your needs. And finally, we have to again add what the assistant said to the communication thread. Because the assistant forgets immediately everything it ever said, and you have to remind it again. But at the end of the day, is that complicated? No, it's not. It's really just a 3-liner. It's really not complicated. Now, to have a little bit of fun, I decided that we are talking with a pirate's parrot, mocking us a little bit. Let's see how that works out, and let me show you how this works. I will run my application. Here it is. R. What be you wanting to know? Okay, what should we type in? Who are you? And you will see we wait a little bit, and here we get the entire message back from the pirate's parrot. You can read it if you want. It's kind of funny, I tried it before, but I don't want to talk about ChatGPT today because, yeah, it's hilarious if you ask it questions like that. I'm really enjoy it very much, but you see, it works perfectly fine. It wasn't complicated, First scenario done. It was the most simple scenario, very easy to do. Okay, any questions about this scenario? Are we good? Yeah? Good. Next scenario. The next scenario already is a little bit more interesting because now we're going to use Azure. And here we need the companion package. Can you remember what the companion package is? This was the .NET OpenAI package. But if you want to hook it up with Azure OpenAI, I deployed a model up front in Sweden. So we have OpenAI deployment of GPT-4o in my Azure subscription inside of the European Union. Then you need to use this companion package. And the usage is rather simple. As you can see here, what you essentially do, you are newing up an Azure OpenAI client. You're providing the endpoint of your custom deployment in Azure. By the way, I have a second talk today where I go in very much details about Azure and how you run this professionally and so on. And then you provide some credentials, either key credentials or managed identity or whatever you want. And finally, the chat client is retrieved using this call. So we use the companion package to get the chat client that we have used before a minute ago through the companion package. And then we use exactly the same API that you saw me demonstrating 2 minutes ago. So this is just the entry door to the chat client if we want to use it in Azure. I think that's a pretty nice design, isn't it? So these two packages go hand in hand. Then I call exactly the method that I showed you above. Nothing new to learn here. So let me prove to you that this really works. What is the black pearl? And probably the parrot will tell us something about the black pearl and Jack Sparrow and whatever. You see, works perfectly fine. This answer was now generated in Sweden in an Azure data center in my deployment of OpenAI, and it worked perfectly fine. So all the different scenarios that you're going to see from now on are going to use OpenAI, but it would be really simple to redirect them to your own Azure deployment if you want. There are only a few features which are not available in Azure currently. For instance, the retrieval tool feature from the Assistant API. This is not available in Azure. But I would say 95% of all the features are available in Azure. And the REST API is compatible. And I think that is great news. That makes our lives as .NET developers a lot easier. Okay, so second scenario, check. Are we good? Questions? Fine. Yes, question.
In this case, however, the parameter you provide is the... So in this case, the parameter you provide is not the model itself, but the deployment you did in Sweden.
Oh, very good question. Very good question. Yeah. So later on in my second talk, I will go into very much details about the Azure deployment of OpenAI, but I can quickly do a teaser and show you how this looks like. What I did is I deployed OpenAI, as you can see it here, and in my OpenAI deployment, I can switch to the Azure OpenAI Studio, which will hopefully open up in a second. Yeah. Of course, I have to sign in again. Of course. Yeah, now we are here. And what you see here are my deployments. And what I did, I called my deployments just like the modal that it's using behind the scenes. So if I would give that a name, I don't know, Rainer's Great AI Model, then I would need to specify here Rainer's Great AI Model and not GPT-4o. Does that clarify the question? So you were perfectly right? Yes, and I hope now everybody is on the same page. Great question. Thank you very much. Additional questions? Fine. Good. Next scenario. Now the next scenario is a little bit more difficult. Oops, I didn't copy everything. I'm sorry. Give me a second. I'll copy it again. Here it is. Because now we are going to use streaming. I hope you're all familiar with streaming. When you talk to ChatGPT, you typically see token by token by token. Many people think that this is a, I don't know, CSS typewriter effect. It's not. It's really the LLM spitting out tokens over time. So you see the first ideas of the LLM before it finished, it finished its, let's say, thoughts, if you want. So you are getting intermediate result up front. And of course we want to have the same functionality here in our .NET application. Now, many things are similar. We are still using the production API here. We have the list of chat messages. I talked a lot about this, so probably you are perfectly fine with that. We also add what the user said to the message history. I guess you understood that now. But the important thing is this guy here. We now use complete chat streaming async. And the beauty of this SDK is that it makes use of .NET's iAsync enumerable interface, so you can use a wait for each. Let me describe what's going on behind the scenes before we move on. If we have, no, let's do it like that. If we have our console app here, and let's use a different color, we have OpenAI here. Now what we are going to do is we are going to send the input of the user to be more specific, the messages, the entire message history of the communication thread to OpenAI. And then I'm going to use another color here. OpenAI will send us snippets, tokens, token by token by token until it's done. And the protocol that is used behind the scenes is called SSE, Server Sent Events. If you're not familiar with SSE, it's a pretty old protocol from the web developers are probably familiar with it. It's pretty simple. It's just not sending the entire HTTP response in one go, but it keeps the HTTP connection, the TCP IP connection open, and it sends key value pairs with event names over the wire. So it sends a small SSE event with just the first token. Then it waits a little bit until it gets the next token from the LLM, and then it sends the next token and the next token. So we have a single HTTP response, but it is kept open until everything has been generated. And in the meantime, you get a lot of SSE events sending the different tokens from OpenAI to your application. And the whole process of this SSE stuff is now abstracted away with this beautiful keyword here. Await for each, and you're done. And behind this await for each, you have the open HTTP response receiving server sent events. Very good? So many people think that they are using WebSockets behind the scenes in ChatGPT. They don't. They use an older protocol, which is only unidirectional. It can only send data from the server to the client and not from the client to the server. Okay? Very good? Fine. So what we essentially do is we say streaming await for each, and then we need another for each because it might happen that the server sent us multiple tokens in a single server sent event. That is not really important, and then we write the token onto the screen, and that's it. The only thing that we need to do at the end, we need to add the entire message to the thread history. But we never get the entire message. So what you need to do is you need to combine it using a string builder, for instance, and use the built message in your message history, and the rest is exactly the same as you saw it before. Let me show you how this looks like. Anybody having an idea what we want to say to our parrot? Let's ask him, do you wear an eye patch? Let's see what the parrot has to say. Do you see it? Do you see the scream? Did you see the screaming? Streaming? Please elaborate. Yeah, now you get a little bit more and you get an idea. Okay? And the parrot even uses emoji. I like that very much when it sends us even combined emojis. the skull and the parrot combined. I really like that. So you got the idea. That is streaming. The good news is for you as developers, it's super simple because it's just a wait for each, and that's it. Behind the scenes, you now know it's server-sent events. I recently, I think 2 weeks ago, did a longer talk at another conference here in Vienna where I went much deeper into server-sent events. I introduced the entire protocol and we analyzed the protocol that OpenAI uses in very much details. It was focused on TypeScript and JavaScript. Just take a look at my LinkedIn profile. I have a link to the YouTube recording of this talk. So if server-sent events is something of interest for you, just take a look at my LinkedIn profile and watch the video. I hope it will be interesting for you. Very nice. Streaming. Check. Do we have any questions about streaming? Marvelous. Perfect. Let's go to the next scenario. We are raising complexity. So, the next scenario is about the brand new Assistant API. Now, what is the Assistant API? For those of you who are not that familiar with the whole API stuff from OpenAI, you see here in the API reference, you see the chat interface. Now, this is the API which is in production. This is what you can use. And don't mistake the NuGet package not being productive versus the REST API being productive. So we are using a productive REST API from OpenAI through a beta version of the NuGet package in .NET. Okay, to be very clear. If I scroll down, you see here the Assistant API. And this Assistant API is preview. So now it gets funny. The support for the Assistant API inside the beta NuGet package is additionally marked as experimental. So we are using an experimental part of a beta NuGet package to access a preview API provided by OpenAI. Hey, we are really standing on the edge here, right? That's bleeding. No, I'm just kidding. It's rather stable. I have really good experiences with this API. I'm really just joking. But what that means is that all these API services maybe break. So if you start developing now, you cannot bet the farm that your code will work in 2 or 3 weeks. They might decide to turn the whole API upside down. It's very unlikely, but they reserve the right to do so. Okay? But my experience is pretty good with all this stuff. I've done dozens of trainings and projects and with different customers, and I really have good experience with this stuff. So let's take a look at the Assistant API. For those of you who are not that familiar with the API itself, there is one huge difference of the Assistant API with the previous or currently in production Chat API. The Assistant API got memory. Now, suddenly, the AI can remember what it said. It remembers what you said. You do not need to send the system prompt over and over again. It remembers these things. So it's much easier to write a real-world application with the Assistant API. Of course, the Assistant API got more complex than the old one. The old one was essentially one endpoint. That's it. But it was completely stateless. Now we have a stateful REST API with CRUD operations, create, read, update, delete. You can create a so-called assistant. You have to create a message thread. You have to create messages. You can list the messages. You can delete messages. It's really a REST API, as we all know it. And at the end, when you added all your data, the assistant, the thread, the messages, at the end there is one important operation which is said, run. Run means, hey AI, now take a look at the communication thread and generate your next answer. And it will automatically insert this answer in the persisted communication thread. Now, some users like that very much. Some users really dislike that. Why? Because suddenly this thing stores data. maybe personal information, maybe security relevant data. It depends on what you say to the AI. So therefore, if you use the Assistant API, it becomes super important that you care about security. If you build a bot and your big CEO of your company is using this chatbot to discuss the future strategy of your company, she will be probably pretty mad if you take the API key and give it to the intern who just works for 2 weeks at your company, because then this intern can simply take a look at the files that she uploaded, for instance. Not a good idea. So keep that in mind. Maybe the Assistant API will raise the importance of security, of data sovereignty, of keeping all this data inside of the Azure data center, of maybe providing a custom encryption key to encrypt it with your own key and not with a Microsoft managed key. All these things suddenly become more important because OpenAI is storing data. Good? For us as developers, life becomes easier. For the CSIOs, the Chief Security Information Officers, it becomes a little bit harder. Good. Let me show you a few important things. First, we need the assistant client and not the chat client. Now, please take a look at a function like that. The REST API has a list operation, so you can page through all assistants or messages or threads, a typical paging operation. And it supports returning only a limited number of rows. Imagine that you have 1,000 assistants. You cannot say, give me all 1,000 assistants. It doesn't work like that. You can get the first page with 25 and then the next page with the next 25, and that's kind of tedious to look through in C#. And the good news is, again, the developers of this API, they equip us with iasync enumerable. So if you want to read through data, again, you get full support for await for each, and you do not have to care about paging at all. Good news, makes life easier. Good. So now let me show you how you work with the Assistant API. First, you can access an assistant, you can delete an assistant, you can create an assistant. Now what is an assistant? It's just master data. It has a name, it has a description, it has a system prompt, maybe it has some function tools, or maybe some files are associated with this assistant. This is what you typically manually do in ChatGPT. You upload some files. Some of you are familiar with custom GPTs. That is the developer version of custom GPTs. The assistant is the developer version of custom GPTs. If you're not familiar with custom GPTs, this is your homework. Okay, take a look at it. It's cool. It's really, really cool. Now, as you can see, again, I have my system prompt, same as before. And now, again, you see the REST nature here. I'm not maintaining my own collection of message history. I'm really here creating a thread, a communication thread. I'm creating a message. I'm storing the messages in a database maintained by OpenAI, not in my own memory or not in my own database. Got it? You see the difference? It's really useful. Okay. And finally, you simply say create run. And again, I decided for streaming. Now you are already experts of streaming. You know it's server-sent events and so on and so on. And the beauty here is this await for each. We already had that before. But here you see create run. This create run will start the AI. And by the way, the entire REST API is free. So you do not pay for the REST API calls, creating an assistant or creating threads. It doesn't cost you any money. Just running the threads. That is what costs you money. There is one exception. If you upload files through this SDK, you have to pay for the storage that these files need. Please take a look at the pricing sheet of OpenAI to understand more. Now here you see I'm printing it on the screen, and just for demonstration purposes, I'm getting the number of messages in my communication thread and printing it on the screen. Again, note, I'm not maintaining my own message history. This is done by OpenAI. Okay, let's give it a try. Let's see if our parrot is still there and is still talking to us. You are just an ugly bird. Let's see what it says. It writes, Perfectly fine. And see, 3 messages stored in the message thread. It's very important to understand that each thread is identified with a thread ID. And there is, listen closely, I choose my words carefully, there is no list operation for threads. So if I want to read what you said to the AI, I need to know the thread ID. I cannot go to the assistant and say, give me all the thread IDs. This operation doesn't exist because of security reasons. So keep your thread IDs like secrets. Don't expose your thread IDs directly to the end user, because they might use the thread ID for an attack. Okay? It's not just the API key, it's also the thread ID. There is no list operation there. Also, you can delete the thread. So you can immediately garbage collect threads which are no longer needed. So if you have some sensitive data transferred to the AI and the user logs off, you can delete all the threads. That makes your system a little bit more secure. Good? Understood? Assistant API clear? Now let me prove to you that it really worked. We can go to the dashboard, I can go to the assistants, and here you see this is the pirate parrot. This is exactly what we created. Worked like a charm. Good. Assistant API. Next scenario, check. Good. Last scenario, and then we do a Q&A and a summary. We have 10 minutes, right? Yep, perfect. Now, the last example is about embeddings. Let me comment that out. Let me ask you a quick question. Who in this audience does not know what embedding vectors are? Okay, I would say a third, something like this. So let me quickly bring you on speed. That's your second homework of today, by the way. You definitely have to read up in embedding vectors, because embedding vectors are a super important concept when you work with AIs. Embedding vectors are a collection of floating point values that you can get from the AI based on text. So what you essentially do, you take some text, for instance the text, I like going to the gym. You send it to the AI and what you get back is a vector in a 3072 dimensional space. So this is the kind of space that we deal with every single day, right? Everybody can imagine a 3072 dimensional space? No, of course not. You can probably only think in 2 or 3 dimensions, that's fine, but mathematically it really doesn't matter. If it's 3 dimensions or 3000 dimensions or 1500 dimensions, really doesn't matter. The math is the same. So what we essentially get as .NET developers is a collection of a few thousand floating point values. Now what are these floating point values all about? They are capturing the content, the meaning of the sentence in numbers. It's just like NZ or ASCII. If I tell you A, you know that your computer cannot work with A. It's transferred to 65, right? And the same is here. But this AI is a little bit more sophisticated than just ASCII. So you give it a sentence or a paragraph or maybe an image or a sound file and it will give you back numbers. What can you do with these numbers? Well, essentially nothing. You don't know what these numbers mean, but what you can do is you can take a second sentence. You can do the embedding vector again and then you can compare these vectors. And the more similar the 2 sentences are, the more similar the vectors will be. So you can calculate the so-called cosine similarity of vectors. I have YouTube videos online where I go in very much details about the math and so on. You can look me up on YouTube and you can watch it. Essentially what you do, you can compare the similarity of meaning. And that is the most important building block for search engines. That is what you do. Imagine that you have thousands of knowledge base entries in your own company. And then a user says, I want to know about pirate parrots. And now you have to look through your knowledge base and find an article which is relevant for pirate parrots. That's a really difficult thing to do, not with embeddings. You simply calculate all the embedding vectors of your knowledge base, you calculate the embedding vector of the question of the user, and then you compare. Then you sort, and then you're done. That's essentially what a vector-based search engine works like in a nutshell. Of course, in real life, it's way more complicated, as always, but I try to describe the context in a simple way so you get the idea, and from that on, you can do your own reading and so on. So what I did in this example, it's rather simple. What I did, I created a bunch of pirates. Captain Redbeard, or Blackjack, or One-Eyed Willie, or Mad Mary. She's dressed in a green dress and has a dagger and a black on her left eye. So I just generated a bunch of fictitious pirates, right? And now I would like to create a pirate search engine. I can say, who is dressed in green? And we will get back Mad Mary. Get the idea? That's the whole idea. So what I do here is I am using the embedding client. And that's the important thing for .NET here. There is an additional client, it's called embedding client, and you're going to use one of the embedding models of OpenAI, which nowadays is either text embedding 3 large or text embedding 3 small. I'm not going into details here. I only have 5 minutes left, so read it up yourself if you're not familiar with these modes. Then, what you essentially do, you are going through all the different pirates here. You see that? Let me do that here. You go through all the different pirates and you generate the embedding vector for each entry in your knowledge base. In real world, you would store that in a database, so you do not need to recreate the embedding vector over and over and over and over again. For that, there are so-called vector databases, but that is way too broad topic for my talk today. For now, we're just storing it in memory. Okay, we're just storing it in memory. Then we ask the user, hey user, what do you want to know? Describe the pirate that you're looking for. And then I'm creating the embedding for the question of the user. Got it? So now we have the embedding vectors of all my pirates. Then we have the embedding vector of the question of the user, and then we can simply do a vector comparison. For the mathematicians in the room, the cosine similarity is the dot product of the two vectors divided by the magnitude of both vectors multiplied with each other. For the mathematicians in the room, the magnitude of an embedding vector from OpenAI is 1. It's just defined. It's always 1. So if we multiply 1 by 1, it's still 1. If we divide by 1, it's still the same value. So the cosine similarity for OpenAI generated embedding vectors is just the dot product of the two vectors. And as .NET developers, we have a great feature in the .NET class library, and this feature is called vector. There is a class which is called vector, and it supports hardware accelerated vector multiplication. So I added this small helper function. It uses SIMD, same instruction, multiple data. So it uses hardware acceleration for the dot product of two vectors for implementing my own poor man's vector search. Of course, in reality, you will use SQL Server or Azure AI Search or Cosmos DB or whatever you want to use. But I wanted to show you how it works in .NET, because this is a .NET talk. Take a look at the code if you're interested. At the end of the day, we are just calculating the similarity of the vectors, ordering it descendant, and then we simply get a list of the most similar pirates. And last but not least, to implement a complete RAG solution, I'm putting the most similar parrots into another chat request and ask ChatGPT, hey ChatGPT, for this question I found those pirates. Please formulate a nice answer for the user. And that's the so-called RAG solution, Retrieval-Augmented Generation. And here you have a blueprint how you do it in .NET. Again, if you're not familiar with RAG, Retrieval-Augmented Generation, that's your third homework of today. You didn't imagine that you get so much homework when you came here, right? Okay, that's it. Just kidding. So let's give it a try, okay? Final demo. let's run it. Wer hat eine Augenklappe? I'm using a German sentence here just to show you that our parrot can talk German too. Arr. Zwei Piraten haben eine Augenklappe. Ei. One-Eyed Willy und Captain Redbeard. I checked it up front. It works perfectly fine. Wonderful. And it also gives us details. If we take a look at One-Eyed Willy, for instance, here, where is our One-Eyed Willy? Here it is. He has it on the right eye. See? Or I can ask, who is dressed in green? And it will do rag. It will do the whole embedding stuff. And it tells me that Mad Mary, she'd be wearing green and sporting parrot hat with a red ribbon. Yarr. That is what we get. So you see, it works perfectly fine. You can try it on your own. It works. The important thing is not so much the RAG stuff, because either you already are familiar with embedding vectors and RAG, or you have to do some additional readings after this talk. My important message here is that all these functionalities, the basic building blocks from OpenAI, are wonderful to consume from .NET with this new NuGet package, OpenAI, and its companion package, Azure.ai.openai for Azure connectivity. And that is exactly what I wanted you to see. So I promised you 45 minutes of .NET. I promised you to introduce you to the API, to show you the latest bits that are currently available. Please use the time after this talk to either talk with me. I'm here the whole day. Take a look at the sample code. I showed you the link at the beginning, and again, I'm going to show you the QR code. Just maybe you missed it. Here you have the QR code again, and that's it from me. I already asked during the talk for questions. I don't know if we should do a final round of questions. Do we have any questions? Yes, we have questions. Let's take 1 or 2 questions and we are done, okay? Yeah.